welcome back. Hopefully you're coming back and you've watched the other modules, but if not, if this is your first module, that's great. This is Module 11, Network Address Translation, 11 out of 14. So if you're watching this, we're almost done. It's been a lot of work to do these, and I'm sure it's a lot of work to watch these. It's a full week of work, if not more. So we're going to go through this whole module and do one really hard lab at the end. I got to tell you, though, if you're studying for your CCNA objectives, this is a very important module. You have to know your NAT/PAT, so Network Address Translation, Port Address Translation. You have to really understand it. You've got to be able to configure NAT on a router. But I'm going to explain to you what exactly you need to know for the CCNA objectives. In other words, I'm going to get down to the nitty-gritty and not give you too much information, but make sure you understand the complexity of what you need to know without making it too hard. Okay, let's go ahead and get started on Network Address Translation. So why use network address translation? Because we have inside private IP addresses and we want to get onto the internet. That's really what we need to do in this objectives for the CCNA. We need to configure a NAT border router to the internet. So we're going to use NAT if we need to connect to the internet and your hosts do not have globally unique IP addresses. Okay, some advanced uses for NAT that we don't have to worry about in these objectives are changing over to a new ISP that requires you to renumber your network and you don't want to. Or you have two intranets with duplicate IP address ranges and these merge. We can use NAT to have them both communicate. Again, that's above and beyond our objectives, thank goodness. So we're going to go ahead and learn. We're going to take a private IP address scheme and be able to configure it to get onto the internet. That's our goal. Now we must understand some terms. Local and global. Local addresses are used before translation. Global addresses are after translation. So we must remember an inside local is your inside source host, that's your private address. And inside global is your host's global address. In other words, it's your translated address. So your inside host is basically going to have two addresses as far as the router is concerned. It's going to have your inside local, which is your private IP address, and your inside global, which is your translated address in which hosts on the internet see your IP address or see your host as. There's also something called outside local, outside global, which would be the hosts on the internet for our CCNA objectives. Now remember, those terms can be used differently for more advanced uses, but we don't need to use them in more advanced uses. We just need to use inside local, inside global, and then outside local, global. Doesn't matter the difference between those for what we're trying to do. Inside local is your host before translation. Inside global is your host address to get out on the internet. Simple NAT overview is something like this. There's inside private IP addresses, and then there's the internet. So we need to be able to configure this router without looking up the answers. This router is going to create a NAT table. Say, here's my inside local IP addresses of 10.1.1 and 10.1.1.2. Whenever they go out, they're going to use these addresses. 10.1.1.1 will use 170.168.2.2, and 10.1.1.2 would use 170.168.2.3. That's how we're going to be known on the internet. This router then, when it receives a packet for 170.168.2.3, says, oh, you mean 10.1.1.2, and forward it here. So this NAT table is very important, and this is going to be on our gateway to the internet typically. So we're going to have three different types of NAT: static, dynamic, and something called NAT overload. And NAT overload is what we'll use in our lab. Static addressing or static NAT means we're going to have a one-to-one translation. And this is an example of static NAT. 10.1.1.1 says always use 170.168.2.2. It's a very simple configuration actually, but it's not really good for our corporate networks today. So what about dynamic NAT? Not so good as well. We can use it, but it's really static NAT without having to type in all the work of every single address. For example, let's say you have 200 users. You're going to create a pool of addresses that a host can use when it goes out on the internet. When it comes back from the internet and is done, it'll drop that address back into the pool and make it available. It's pretty hard to imagine these days that you can have hosts within your internet go out to the internet and everyone can use a separate IP address. So in other words, you have, let's say, a block size of 64, which gives you 62 hosts, and you have 200 users, and say, well, only 62 hosts can get it at a time, get to the internet at a time. That doesn't seem too realistic today. I could just imagine what it would be like in a corporate office. It would be a lot of chaos, wouldn't there be? So nonetheless, dynamic NAT is a lot like static NAT, except that we have a pool of ranges that the host will use instead of having to type them all in by hand. Now, port address translation, or NAT overload, allows us to use a single address for everyone on my network to get onto the internet, and we can have over 65,000 hosts use this single address. That's crazy to think about, but I've known people that have done it. Typically, you want to keep the range, Cisco says, to around 3,000 hosts per connection to the internet. To me, that seems like an awful lot still, but I guess it depends on the bandwidth. So NAT overload is what we're going to use today. So if you get a little Linksys router, you come home, you connect that to your cable modem or DSL, you have all your hosts on the inside. The reason that we're able to do this is because of NAT overload. We use one address that we get from the ISP through DHCP on our Linksys router, and now everyone uses an inside local, and everyone uses the same inside global translated address to get out. Again, this is called NAT overload, or port address translation, and I'll explain how that works in a minute. So to translate inside local address, remember, what are the addresses called on these hosts? What do we call these when we're talking about NAT? Inside local. When they're translated here on this router, they're called inside global. So these hosts are known as the internet as inside global addresses. These are considered inside local. Now, the hosts out here are called outside local, outside global. So we want to be concerned about our inside local being translated to inside global and how they're going to get out. And we can do that one of three ways: static, dynamic, or PAT. So if we do PAT, we also call this overloading. And we can see the NAT table is much different than when we were using static NAT in the example on the page before. We still have our inside locals, but everyone uses the same inside global. Check this out, 170.168.2.2. If that's the case, and host B sends information back because 10.1.1.1 was, this is IBM.com server, whatever it is, and this host sends data and trying to do a web browser, and this is sending the information back here, it sends it to 170.168.2.2. Well, how does this router know how to give it to 10.1.1.1 since we got the same destination IP address? This is where port address translation comes in. First off, we're going to have the protocol, which is TCP mostly. Certainly can see UDP here, but we use our source port numbers. When a host makes a virtual circuit to a destination, it's going to make up a source port number and use the destination port number. An example here, we're going to use port 23, which means we're what? Telnetting out here. And then our source port number we make up. So this is the router keeps track of us based on our source port number. So in other words, if I come out here, I make up a source port number, this router remembers it and forwards it based on destination port 23, source port number 1492, or in this case, 1024 for 10.1.1.1. When this sends data back, it's going to say destination port 1024, send it to 170.168.2.2. And so we're going to come back and say, oh yeah, everyone's 170.168.2.2, but we need to send it to port 1024. Who's 1024? 10.1.1.1. This is why it is called port address translation, because we use the source port number to differentiate between all the inside locals. Everyone uses the same inside global to get out. This is why we haven't run out of IP addresses going to the internet, because the NAT or PAT has conserved IP addresses tremendously. I'm not saying that this was good, because I think IPv6 is a better addressing scheme, so PAT in some senses maybe have ruined our lives and made us not convert to IP6 faster than we should have, but nonetheless, we have IP version 4, and we're probably never going to run out of addresses with IP version 4 because of port address translation. Now, again, this is inside local, inside global. Now, if I come up here and I make up a source port number, and now this host comes up and say he uses 1024, and 1024 is already in use here. So the router's going to knack this, and he has to use another source port number. Now, we could use a pool of addresses here. In other words, you don't have to use one address, 2.2. We can get a block size of 8 and have 6 hosts here. So what happens if he comes up, this host comes up, and it's knacked because the source port number is in use? It'll use the next IP address in the range. It doesn't give us better bandwidth, make anything more efficient. It just stops hosts from being knacked because we'll use more IP addresses. So if we're knacked, we'll use the next IP address in the range, and so on. So if you have a block size of 8, you get 6 hosts. In a large corporation, that's probably better. Remember, this doesn't make it faster on the internet. It doesn't make it run better. It doesn't give you more bandwidth. All it does is make your host communicate to the router more efficiently. So I highly recommend it if you have thousands of hosts using one router and you're using PAT. Now let's take a look at a basic static NAT configuration. It's really simple, 3 lines. We have our inside network, inside local, our inside global. This is connected to the inside and the outside. IP NAT inside on Ethernet 0. IP NAT outside on serial 0. Now, IP NAT inside source, so we're saying the source is from the inside, going out. Static NAT 10111. If you're trying to go outside to the internet, use 172.46.2.1. So we have a 1-to-1 translation here, and if I had 100 hosts, I'd type this line in 100 times. It's a pretty simple configuration though. Static NAT has not outlived its purposefulness. We are certainly going to use PAT on our corporate networks today, but we're also going to use static NAT because if we have a DMZ and we have private IP addresses on our servers, our email server, web server, and so on, we are going to use static NAT to communicate because we want those addresses to stay the same and be static for our DNS services. So static NAT and PAT we're going to use a combination of those on our corporate network. But having everything as a static NAT today is really out of line. It's just not going to be able to use in our corporate network. So we will see a combination of static and PAT on our corporate networks today. Let's take a look at a configuration of dynamic NAT now. Now there's a couple different ways to configure dynamic NAT, and really this is the beginning of how to do PAT as well. You know we have to have a couple commands here. We still have the IP NAT inside source command. We're going to have our inside and outside configurations, so these 3 lines still stay the same, although we changed this line a little bit. We add an access list. Now remember, this isn't applied to an interface. This says who can use the pool, because here's where we list the pool right here. Say list 1 pool, and this is saying who's permitted to use the pool, and that's the source is this. So the access list is not added to an interface. It's just saying who can use the pool. So IP NAT inside source list 1 pool dynamic NAT. So the dynamic NAT pool is created up here. IP NAT pool dynamic NAT. Now you can name this Bob or Todd, whatever, but this must match exactly here. In other words, it is so case sensitive it's not funny. A lot of times in my classes, most of the students will not type this in correctly and they'll say pool not available, because the access list is allowing people to get to that pool, but the pool it's trying to get to doesn't exist because it's very case sensitive. So IP NAT pool dynamic NAT, you can use the pool as 171.68.2.2 through 2.254, and of course we had our mask. So now, when anybody from the inside is trying to go to the outside, they're going to grab one of these IP addresses that are available, go to the outside, do their work, come back, and drop it off back here into the pool and make it available for the next person. Now you could type this in another way. Forget about typing in this pool part, but we're going to do this in our lab, something like this. We could say IP NAT, we don't even need this line up here if we do this, IP NAT inside source list 1, interface serial 0. That's what we would type in, and now we have our inside, outside, and our access list, and this just, we don't need the pool because it says use just this IP address. That's if we're using the overload command, which I'll show you right now. So in this case, check this out, this pool. IP NAT, since I'm going to use inside global address overloading, IP NAT pool global net, 171.68.2.1 through 2.1. I have to have the beginning and end with the mask. And now I can say IP NAT inside source list 1. Here's my list, who's permitted to use the pool global net. Now this better match exactly. You better not have a capital G here and not one here. It will not work. And I use the overload statement, and this will allow me to configure PAT on here, and I only need 1 IP address. We only have the one available, which is the same as here. This is kind of too much work, actually. We should just do this. IP NAT inside source list 1 interface serial 0/0 overload. Then we don't even have to type the pool because we're using the 2.1 anyway, so this is kind of redundant, isn't it? But nonetheless, we're going to do it like this in our lab because we're studying for the CCNA objectives. So we're going to type IP NAT pool global net beginning and end address. We're going to make them the same, or we might add a couple extra addresses in here, but it really doesn't matter. The only reason we'd add a couple extra addresses is to make people sync faster. And then we're going to add our inside and outside and then our access list. So IP NAT inside source, list 1, pool, global net, and this is going to match. So this is how we'll end up doing our lab, exactly like this. And then put our inside and outside in our access list. And I have to tell you, you absolutely have to know how to do this, and you have to be able to do this without looking in the book or looking on the slides or whatever you're looking at, reading it in the book. You have to be able to type this in. So I encourage you to get the routers that I'm getting or get any type of routers that can do NAT and figure the lab I'm going to do over and over and over again until you can do it without looking. Now, to verify NAT, it's very easy. Show IP NAT translations. And this is if I was using static NAT, it would look something like this. Inside local, inside global. We'd see our translations. Are we doing dynamic NAT here? In other words, where we have a pool? I don't know. Static NAT is the same thing. Dynamic NAT just means you have a pool of addresses to use instead of a one-to-one translation. You have to type in one by one. A pool just says use this pool. Where there, if we do a show IP NAT translations, it's going to look just like this. Inside local, inside global. A one-to-one translation. Now we know if we do a show IP NAT translations and we're running PAT or overload, it's going to look like this. We have our inside local, our inside global, and we can differentiate between the two based on what? The source port number. So anything from the outside local and outside global is going to come back and have a destination of 170.168.2.1 with a destination port of 11,003. It's going to look up based on the source port number, in this case 11,003, and send it to 10.1.1.1. So you can see we have more information here for using overload. Now, one of the other things that we can have a problem with NAT in the sense that if we have thousands and thousands of users, we can get thrashing of the NAT table. So a lot of times we might have to clear it out. But be very careful with this command. If you're doing this in a production network, you bring your network down. Anyone going to the internet typically is where we're using NAT. Clear IP NAT translations space asterisk. Clear IP NAT translation space asterisk. I'll do it in the lab, but you should remember that command. But remember, that's a very powerful command, and it clears the whole NAT table out. So if one person's having a problem and no one else is, do you really want to clear the whole NAT translation table? But if people are going up and down, this is a indication of a thrashing of the NAT translation table. So you might want to clear the NAT translation table and check that out. Now to troubleshoot NAT, we're going to use the debug IP NAT, and I'm going to turn this on in our lab. Now with this command, you really can't use this in production if you have dozens or even hundreds of users. This is just going to fill your console up. But we could see this is my inside local, inside global, outside local, outside local, inside global, inside local. You can see the data coming in and back. So it's kind of nice in a very small environment. It's great for a classroom environment, or if you're doing videos, or if you're doing labs, something like that. And you absolutely should be using this at home with your routers. Debug IP NAT. So I know this wasn't a very long section. I encourage you to read chapter 11 of my book or read about NAT because we really do need to understand NAT. I summarize the basics of what you need to know, and with the lab I'm going to show you what you must be able to type in. So let's go ahead and do the minimum amount we need to do. You take an inside local, translate it into an inside global, overloading, everyone using one address. It's very important that we can do this, so I'm going to make sure and do this lab nice and slow for you. Let's go ahead and take a look.